Hello students, welcome to Educate. In previous lecture, we have studied the basics of vectors and we tried to find out the resultant of two given vectors. Today again we will continue with that concept. So let's see this question. Question number 4. It says, at what angle do the two forces P plus Q and P minus Q act so that their resultant is 3P square plus Q square under root? So here you are given two forces. One is this, another is this. This angle is theta, and one force is P plus Q. Another force is P minus Q. And condition is their resultant should be, this is the resultant, say 3P square plus Q square under root. So how will you proceed for this? If you remember, I told you the rule to find resultant. Resultant is found by using formula. First vector a square plus b square plus 2ab cos theta. Here our concern is to get theta. So it is simple. So here, at what angle do the two forces act so that their resultant is this much? It means value of r is this much. So here you can write this value. And if you square it, it will become r square equal to a square plus b square plus 2ab cos theta. So in place of r square, we write 3p square plus q square. So let's make more space. So that will be better. So we write 3p square plus q square is equal to p plus q square plus p minus q square plus twice of p plus q times p minus q times cos theta. Our concern is to get the value of theta. So we just open the bracket. 3p square plus q square is equal to, this is p square plus q square plus 2pq. The first one. Second one will become p square plus q square minus 2pq. Plus third one will become twice of p square minus q square times cos theta. Now here 2pq will cancel out. This p square will become 2p square. This q square will become 2q square. So we can do one thing. We can take this 2p square to LHS, 2q square to LHS. So this will become 3p square minus 2p square plus q square minus 2q square is equal to, in RHS, twice of p square minus q square times cos theta will be left. This will give p square, this will give minus q square. So p square minus q square equal to twice of p square minus q square times cos theta. Now if we divide by twice of p square minus q square, we will get cos theta equals half. And if you remember, cos theta is half when theta will be 60 degree. So theta is not q, this is theta 60 degree. So we have got the answer. Now let's take another question. Next question is, here if the angle between two vectors, I think screen is visible, if the angle between two vectors of equal magnitudes is 120 degree, then show that their resultant is equal to either vector. So here two vectors are equal and Angle between them is 120 degree and you have to find out their resultant. So suppose the two vectors in magnitudes, say both vectors are A. First vector is A, second vector is also A. So a resultant we try to find out and we will see if resultant is also A or not. So R equal to root of square of first vector A square plus B square plus 2AB cos theta. This is the formula. Now let's put the values. So root of A square plus A square plus twice of A into A will become A square into cos of 120 degree. If you remember, I told you how to get cos 120 degree. So suppose this is graph of cos theta. This is 90 degree. Here value at 60 degree it is 1 by 2 and here this is 90, gap of 30. So if you increase by 30, I think you have not understood the point. What I mean, this is 90 degree, 30 degree backward. So here this is 60 degree. Now 30 degree forward, so here it will be 120 degree. So height here to this point is equal. This is 1 by 2 and this will be minus 1 by 2. So cos 120 degree is minus 1 by 2. So if we put this value here, so A square plus twice A square into minus 1 by 2. So 2 will cancel out, this will minus A square. So 1 A square will cancel out and you will be left with the root A square and which will give A. So our question was, if the angle between two vectors of equal magnitudes is 120 degree, then show that their resultant is equal to either vector. So we started assuming that in the beginning we have assumed that both vectors have magnitude A and the resultant vector is also A. Hence our purpose is served. Now we are going to see another vector. So here we are going to make use of parallelogram law of vector addition. We have studied the triangle law. If you remember, I am making you recall the triangle law of vector addition was like this. Suppose this is one vector, another vector is like this. Suppose this is vector A, this is vector B, and the angle between the two vectors is theta. So here we draw perpendicular. We write the component of this vector B. So this is B sine theta. And here base will become B cos theta by using trigonometry. I think you remember basic trigonometry. Then we can say, suppose this is point A, this is point B, up to here, this is point B. So OB will be A plus B cos theta. And here this is B sin theta, this is resultant. So we have a right angle triangle in which base is A plus B cos theta and perpendicular is B sin theta. And suppose this angle is beta. This is resultant. Our concern is to get the value of resultant. So resultant can be found by using formula of Pythagoras theorem. So R equal to root of A plus B cos theta whole square plus B sin theta whole square. If you simplify, you will get A square plus B square plus 2AB cos theta. So this is the formula that we have used in previous problem also. But in order to recall its derivation, I have done it again. Now, what we can do, we can recall the same concept while using parallelogram law of vector addition. So it is simple. Suppose you are given two vectors inclined at angle theta. Suppose this is one vector, suppose this is vector B, this is vector A, and angle between them is theta. Now you have to find out the resultant. So what you can do, just parallel to this vector, you can draw one vector here, so that parallelogram may become, and parallel to this vector you just draw one line here also. Sorry. So this will be equal to vector A, this will be equal to vector B. This angle is theta. The same thing will happen here. This angle will be theta. And now draw perpendicular. This is 90 degree. So again same thing you will get. This will be B sin theta. This base will be B cos theta. So you just join this line. This is resultant. This angle will be beta. So situation is same. Whatever you have done in case of triangle law, the same thing you have to do here also. This will be B sin theta and this is A plus B cos theta. If you find the resultant, same formula, square of this plus square of this, A plus B cos theta whole square plus B sin theta whole square. If you simplify, same thing you will get. R equal to root of A square plus B square plus 2AB cos theta. So what you have observed, there is no difference between the two. Here sides are represented by two adjacent sides of parallelogram. Here two vectors are represented by two adjacent sides of a parallelogram. In that case, two vectors were like this. This was the difference. But both mean same thing. We take this vector can be shifted from here. This vector is here. Now we have shifted this vector to this position because it is not a fixed vector. So you have understood how to calculate the resultant, and if you want to find out the angle that resultant makes with the base vector, so same formula you will apply. Tan, suppose this is alpha, so perpendicular component of B, so that will be B sin theta divided by base vector, means starting from A to E. So this is A and this is B cos theta. So A plus B cos theta. So this is angle that resultant, here AD is resultant, makes with the base vector. Now let's continue. Now we are going to study another concept. The concept is scalar product and vector product. So scalar product we can understand by simple concept. I cap dot I cap, J cap dot J cap, K cap dot K cap is equal to 0, and I cap dot J cap, J cap dot K cap or K cap dot I cap will give 0. Sorry, I am mistaken. Here, by mistake, I wrote that I dot I equal to J dot K gives 1 and I dot J equal to J dot K equal to K dot I will give 0. When two vectors are same, in that case, resultant will be, means I am going to explain you how, what is the basic concept behind this. So let's understand that first. Suppose you are given vector A dot vector B. So a rule is there, you will write the magnitude of first vector, then magnitude of second vector. So suppose we write magnitude of first vector as A and then magnitude of second vector as B, and then cos of angle between them. So cos theta. Now suppose one vector is A, another vector is also A, then theta will be 0 degree. So in that case, it will become, this term will become 1. Cos 0 is 1. So suppose we are taking I cap dot I cap. I cap modulus is 1 because it is unit vector. J cap modulus is 1. It is also unit vector. K cap modulus is also 1. It is unit vector. So now suppose we want to find out I cap dot I cap. We are going to verify why we get 1 or 0. So I dot I will be equal to modulus I times cos, since same vector we have used, so theta will be 0 degree. Now I cap is 1, so 1 into 1 into 1. This gives 1. So I dot I equal to 1. Similarly, if we take J dot J, it means modulus J times cos 0 degree, because angle between same vector will be 0 degree, and you know that this is 1, this is 1, this is 1, so this gives 1. Similarly for K dot K, so modulus K times cos 0 degree, so this will be 1 into 1 into 1, so it will give 1. So you have understood why I dot I equal to J dot J equal to K dot K equal to 1. Now we are going to see why I dot I equal to J dot J, I dot J equal to J dot K equal to K dot I gives 0. So it is simple. Suppose we take I cap dot J cap. So rule says we will write modulus of I cap, modulus of J cap times cos theta. This vector, unit vector, is along x-axis and J vector is along y-axis, so angle between them is 90 degree. So cos, not theta here, just write 90 degree. And you know cos 90 equal to 0. So I dot J will become 0. Similarly, if you take J dot K, so it will become J dot K, by same analogy, this will become modulus of J modulus of K times cos 90 degree, and cos 90 is 0, so result will be 0. Similarly, if you take K dot I, if you take these two vectors, so modulus K modulus I times cos 90 degree. So the concept that we started is I dot I, J dot J, K dot K gives 1, and I dot J equal to J dot K equal to K dot I gives 0. Proof of both you have understood. Now, so by using this concept, we are going to do some questions of dot product. So concept that we will make use will be the modulus of any vector and then dot product of the vectors. So modulus, if you recall, suppose you are given vector A equal to 2i cap plus 3j cap plus 2k cap, and you find its modulus. What will it be? If you remember, we have done it earlier. So square of this number 2 square, then square of this number 3 square plus square of this number. So this will give modulus. And if we have got the modulus, after that we can easily get the angle. So I am going to use the formula vector A dot vector B equal to modulus of vector A modulus of vector B times cos theta. So here this formula will be used for getting angle theta. But suppose you have to directly find A dot B, then what will you do? So leaving this concept here, first of all, we are going to see one question based on the basis of dot product, in which I dot I will give 1, I dot J will give 0. Means if unit vectors are dissimilar, in that case you will say that dot product will become 0. Suppose we have taken this question, or instead of that we can take another vector A equal to 2i minus j plus k, and say vector B equal to I plus 4j plus 2k, and you have to find out vector A dot vector B. So how will you proceed? Here coefficient is 2, here coefficient is 1. since I dot I will become 1, so only 2 into 1 will be left. When this I will get multiplied to j, it will give 0. This I is multiplied to k, this will give 0. So it is unnecessary to multiply. So we can directly multiply the coefficient of II, jj and kk to get the answers. So here coefficient of j is -1 multiplied by coefficient of j is 4 plus here coefficient of k is 1 into 2. If you simplify, this is 2 minus 4 plus 2. This gives 0. You have understood? Now we are going to make use of this formula to get the angle between two given vectors. So as I told you that vector A dot vector B is equal to modulus A modulus B times cos theta. So here, suppose you are given vector A equal to say I plus 2j plus k. So what will you need here? You will need modulus A. So that will be root of 1 square is 1, 2 square is 4 and here 1 square is 1, that is root 6. Similarly, suppose you are given vector B, say I minus 2j plus 4k, and you have to find out its modulus. So modulus B will be root of coefficient is 1, so 1, here coefficient is minus 2 squared, that is 4, and here coefficient 4 squared 16, 16 for 20, 21, root 21. So you have got vector A modulus and vector B modulus. Now what is left? You have to find out LHS also A dot B. If you do dot product of these two, A dot B, as I told you, only you have to multiply the coefficients of I, j, kk, because other pairs will give 0. So I has coefficient 1, here I has coefficient 1, so it will become 1. Then here j has coefficient plus 2, here minus 2, so this will become minus 4. Then coefficient of k is 1 and 4, so 1 into 4. So 4 will cancel out and 1 will be left. So we have got A dot B as 1 and modulus A is root 6, modulus B is root 21. Then we can say cos theta, from that formula cos theta will give A dot B divided by modulus A modulus B. So A dot B, we have got 1, so we write here 1, then root of modulus A is 6 and another one is 21, so we write them together. So cos theta is equal to 1 upon root of 126, or theta equals, we can study the concept of inverse later on. I'm just writing it here, but I will explain you about this inverse thing also. Now here there is one question for you. Find the angle between vectors. These are two vectors and you can find the angle. So you can apply this formula. Now one thing you will observe, that if dot product of two vectors, like suppose vector A dot vector B, you are getting 0. It means they must be perpendicular, because you have seen if I dot j we evaluate, what do we get? We get 0. So definitely here these two unit vectors are perpendicular to each other. One is along x-axis, another is along y-axis. The same thing will happen if there are two vectors and their dot product is giving 0. It means they are mutually perpendicular. So on the basis of this concept, sometimes questions come in which there will be one variable and that you have to evaluate. I am going to show you. Suppose you are given vector A is 4i cap minus, suppose, 4i cap minus 2j cap plus ak cap. Here A is a number that is to be determined, and vector B is given 3i minus j plus 2k, and it is given that these two are giving their dot product 0, that is they are mutually perpendicular. So if they are mutually perpendicular, so you can easily say that A dot B is 0, that is we multiply the corresponding coefficients of I, J, K and we add them and we can equate them equal to 0. So we can put them equal to 0. So 4 into 3 plus 2 into 1 plus 2A must be 0. So this is 12, 14. So 2A is minus 14. So A equal to minus 7. So if condition of perpendicularity is given, in that case you can evaluate some constants or some unknowns. Now let's see some more concepts. Here, find the angle between vectors. This you can do. The same concept I have used. Now there are certain questions. Here I am making the screen little bigger so that you can easily understand. Okay, you can see the question. Find the angle between the vectors I plus j plus k and minus I minus j plus 2k. Answer is coming to be 90 degree. It means their dot product must be 0. You can verify. I am not doing that question. Next question is, for what value of x the vectors xi minus 2j plus k and 2xi plus xj minus 4k are perpendicular to each other? What is the condition for perpendicularity? I have told you that if there are two vectors and their dot product vanishes, means their dot product becomes 0, in that case you can say that the vectors are mutually perpendicular. Same condition you can apply. X, this will become x into 2x minus 2x plus 1 into minus 4 equal to 0, and you can solve to get the value. Here you will get a quadratic equation and you know how to get the values of x if quadratic equation is given. Now let's see another question. So another question is, here you are given, show that vectors this and this, there are three vectors, they form right angled triangle. So what will be the condition? Suppose there are three vectors. If one angle becomes 90 degree, in that case you can say that these three vectors represent the sides of right angle triangle. So suppose this is vector A, one vector, this is vector B, this is vector C. Now what do? First we find the dot product of these two. If we are getting 0, it means these two sides will be represented by these two vectors and angle enclosed between them must be 90 degree. If we are not getting that, I am not doing that, I am just explaining that your task. Suppose you take dot product of these two, you are getting 90 degree, 0. It means these two will be perpendicular on base, third one will be hypotenuse. Or you can take this and last one and then again check. If dot product is 0, it means they will form perpendicular and base, then this will make a hypotenuse. So you have to work and after that you will check which pair is forming base and perpendicular. Definitely one pair will have dot product 0. So this is how you can prove that the three vectors represent three sides of a right angle triangle. Now next question, if unit vectors x cap and y cap are inclined at an angle phi, then show that modulus x minus modulus y is 2 sine phi by 2. Here you are given modulus x cap minus modulus y cap is equal to 2 sine phi by 2. This is little tricky question, but you can solve it. So this can be written as, suppose we take x cap minus y cap, and we find dot product of itself. What do we get? Assuming that x cap or y cap has modulus 1, because in our question it is given that x cap and y cap are unit vectors. Okay, angle between them is given as phi, so let's try it. X dot x, same vectors, so this will give 1 because this is unit vector, this will be unit, so we have got 1 minus another xy. So since they are inclined at angle theta, so either we can write a formula 1 square plus 1 square, but I think it will create confusion. So in order to avoid confusion, I'm directly writing this is x square plus y square minus twice of xy cos phi. Now these are modulus values. So modulus x, modulus y, here you can put cap. So these are modulus values, so each of them will give 1. So 1 plus 1 minus 2 cos phi. You have taken dot product of same. So what you have got? 2 minus 2 cos phi. 2 common, 1 minus cos phi. You have started from here. You are given this only. So we can write this as x cap minus y cap modulus is same as square root of this x cap minus y cap dot x cap minus y cap. Now up to here I think everything is clear. So this term, if we write here, because we have evaluated this and we have reached till here, so we can write this term here. So what will it become? Now from here we have got, it was 2 minus 2 cos phi, if I am not wrong. So 2, 1 minus cos phi with square root inside the square root. Do you remember the formula of cos 2 theta? If you know basics of trigonometry, so in case of cos 2 theta angles, so if you work, you will find cos 2 theta is equal to 2 cos square theta minus 1, or 1 minus 2 sine square theta, or cos square theta minus sine square theta. So these are three formula. You have to check which one is suitable from here. So here 2 theta can be written as theta. It means when we write cos theta in place of theta, then this theta will be replaced by theta by 2. So 2 cos square theta by 2 minus 1, or 1 minus 2 sine square theta by 2, correct, or cos square theta by 2 minus sine square theta by 2. So here we need 1 minus cos phi. So we can do one thing. Cos theta we can shift to RHS and 2 sine square theta by 2 to LHS. So we get 2 sine square theta by 2 equal to 1 minus cos theta. In our question it is 1 minus cos phi. So we can write 2 sine square phi by 2 in place of that. So here, so this will become twice of this 2 and then twice of sine square phi by 2. So this 2 will become 2 and then sine pi by 2. So we have got the answer. This question is little tricky because here trigonometry is being used. If you know basics of trigonometry, then you can do it easily. If there is slight problem, so I am going to explain you that concept of trigonometry so that thing may become easier and you can solve it easily. So let's see some basics of trigonometry. So you know sine 2x is to sine x cos x. Here there will be a question in your mind, why this? So let's go in detail. So there is a formula, sine a plus b gives sine a cos b, sine a cos b plus cos a sine b. Right? Now, if we write a equal to b equal to x, what do we get? Here, x plus x, that will become 2x. So it is sine 2x equal to sine x cos x plus cos x sin x. Sin x cos x plus cos x sin, both are same thing. You can write it 2 times sin x cos x. So you have got the formula for sin 2x. Similarly, suppose you need cos 2x, so we can write cos a plus b. Suppose we take cos a plus b, then it gives cos a cos b minus sin a sin b. Here one anomaly you have to note, when there is plus sign in LHS in case of cos, then there must be minus sign in RHS. So now let's write a equal to b equal to x. So we will get cos 2x equals cos x minus sin x sin x. This gives cos square x minus sin square x. So we have got one formula of cos 2x. Now, if you remember, cos square x plus sin square x equal to 1. So suppose we want to replace this sin square x by 1 minus cos square x. So cos square x 1 minus cos square x. So this will become positive. So we will get twice of cos square x minus 1. So we have got another formula, cos 2x equal to 2 cos square x minus 1. Similarly, if we write here 1 minus sin square x, what do we get? So cos 2x equals 1 minus sin square x minus sin square x, that gives 1 minus 2 sin square x. So we have got formula sin 2x equal to 2 sin x cos x. Now suppose we want to use half angle. So if we replace x by 2, so what do we get? In LHS, twice of x by 2, 2 will cancel out. So in LHS it will remain sin x equal to, here 2 sin x by 2 cos x by 2. So this is expansion. This sin x can be written as twice of sin x by 2 cos x by 2 when we use half angle. Similarly, we have seen, cos 2x as 2 cos square x minus 1. If we want to use half angle, so replace x by 2. So here x by 2 will appear. So this term LHS will become cos x equal to 2 cos square x by 2 minus 1. Similarly, if we want to write the same formula in terms of sine, cos 2x is equal to 1 minus 2 sine square x. Now if we replace x by 2, So cos x will become 1 minus 2 sine square x by 2. And the same thing we have used to solve the problem, this one. So I think you have understood. This is all for today. We will see the vector products in next lecture. Thank you, Team Educate.